Welcome to this video on proving trigonometric identity. So what we have here, the question now is secant x is equal to sine of 2x. So this is double angle. Sine 2x divided by sine x, cosine 2x divided by cosine x. Oftentimes students want to commit the following mistake. They try to divide x by x, or sometimes they think that sine 2x divided by sine x should give you 1 sine x, similarly with cosine x. So this is the common mistake that most people would make, but hopefully after watching this video you will learn that this is not the right way to go. So before we start, let us recall the double angle identities that will be very useful in this exercise. So what you see here, sine of double angle, sine to x is equal to the product 2 times sine x cosine x. Check. Cosine of double angle, cosine to x, there's 3 different variations. We'll use the basic one. Cosine to x is equal cosine squared x minus sine squared x. Check. Secant identity, this is the reciprocal function for cosine, so that is very useful as well in the process of proving this question. And finally, the Pythagorean identity that you have noticed is very commonly applied. Sine squared x plus cosine squared x is equal to 1. Check. So 2 sides here to this equation. The left side has only one function, secant x, and the right hand side has fairly complex statement. So we will start by choice from the right side. So the right side begins. Right away in the first line, we will replace sine of 2x with this identity. So instead of saying sine of 2x, we'll go and say 2 sine x cosine x divided by sine x, of course. Take away, and the second substitution for cosine of double angle, we'll put cosine squared x minus sine squared x. So this is why you see it here. Now, we'll see that at this stage we can simplify. So divide by sine x, this part, and this will give you just 2 cosine x. The next step here shows that we will do the split. So cosine x squared divided by cosine x will give you 1 cosine x, and then negative minus negative sine and negative sine squared x, so you distribute negative 1 to this term, so this is why you're going to have plus, so negative and negative, sine squared gives you positive sine squared divided by cosine x. So over here now you see that we have 2 cos x minus 1 cos x, so this is why put together you have 1 cosine x. So now we are in this third line. So 1 cosine x, and what happens with sine squared x? Remember, sine squared x plus cos squared x is equal to 1. So when you replace sine squared x using this Pythagorean identity, you will show 1 minus cosine squared x. So this is why you have it right here. 1 minus cosine squared x divided by cosine x. Moving down to the next line. So cosine x is repeated. Now we are splitting this. So we did that split already up above here in the first line. So we'll split this expression into 2 rational statements. So 1 over cosine x, take away cos squared divided by cosine x. Going to the next line. So, continuing from here, the first term is just cos x, copy. Cos x, done. Plus 1 over cosine x. Okay, and now divide cosine squared x divided by cosine x. Will give you 1 cosine x. So this is y. You will say minus cosine x. Okay, so 1 cosine x plus 1 over cosine x minus, again, cosine x. So cosine and negative cosine are gone. So what you have remaining here is just 1 over cosine x. So this is to be divided. So, and 1 over cosine x, according to this identity, is simply secant x. Secant x. And secant x, indeed, is our left-hand side. So this is equal to LS. And that completes the proof, because our goal was to start with one side, and in our case it was right-hand side. Conduct the proof by rearranging the given expression until we have received and obtained the opposite side. So now, with pride, you can say, therefore, so I'm going to do it on top, left side is equal to the right side. The proof is done, and you're done. Thank you for watching this video. I hope you have enjoyed it, and I see you next time.